Algebra 2, we're in lesson 11.7, and this is really a probability involving geometry lesson. You're always going to be given two shapes in these scenarios. You'll be given a little shape, which is the gray shaded area. You're also going to be given a large shape. In example 1, you can see that the little gray shape is a square, the big shape is a circle, but in all truth, you're going to see different scenarios. It's not always going to look like that. You might have, and I can draw this off to the side here, you might see that your big shape is a square and your little shaded region could be a circle. You could get two circles. You could have a circle inside of a circle, just like so. But, just stressing the fact that you always have two shapes, it's always going to be in the scenario of throwing a dart and guaranteeing that you're in the big shape. You'd like to find the probability that you're in the gray shaded area, which I've highlighted in blue. So you've got area formulas here. You've got, in fact, 4 basic ones that Alex will show up quite a bit. And as we read this, let's just read example 1. A dart hits the circular dartboard at a random point. That we know to happen. Find the probability that the dart lands in the shaded square region. The radius of the dartboard is 11. Each side of a square is 4. So here's what you're going to always wind up doing. The area of the whole shape is in the denominator. The area of the shaded shape is in the numerator for your probability. You want the probability that you hit that gray target. So you've got your little shape up on top. You've got your big shape down below. So let's look at our shaded shape. That is a square. And I'm looking for the square. It's right here. It's side squared. You could say, well, what's your side? Your side clearly is a 4. So I'm going to just say it's 4 squared. How about the big shape? The big shape, I hope you can see right here, is a circle. And that's pi radius squared. What's your radius here? Well, plain and simply, it's 11. And we want to go to the nearest hundredth here. So we'll just get our calculator out. We'll go turn this on and get alpha y equals. And up on top, we'll have 4 squared. Down below, we'll have a pi and then 11 squared. And we're going to the nearest hundredth, so it's 0.04. And that really is all we need for number 1. As we look at example 2 is really making a sample space diagram to help us see how to do future problems. You toss 2 dice, and I'm going to say over here is die 1, and up here is die 2. And this would be numbers of 1, 2, 3, 4, 5, or a 6. Here we could get a 1, 2, 3, 4, 5, or a 6. And we want to record the sum. Well, if you get a 1 and a 1, that adds up to a 2. You get a 1 and a 2, that becomes a 3. A 1 and a 3 is a 4, 1 and a 4 is a 5, a 1 and a 5 is a 6, 1 and a 6 is a 7. 2 and a 1 is a 3, 2 and a 2 is a 4. I think you get the idea. Very quickly, kids begin to see the pattern. As we're going left to right, we just get one step bigger each time. 3 and 1 is a 4 here, and then we'd have a 5, 6, 7, 8, and a 9. 4 and 1 is a 5, and then we'd have a 6, 7, 8, 9, 10. 5 and 5 is a 6, then we'd have a 7, 8, 9, 10, and an 11. Finally, 6 and 1 is 7, then we'd have an 8, 9, 10, 11, 12. What I've done is I've drawn out the sample space. In yellow are all the possible sums. These are the only numbers you can add up to. You can see we have a 6 by 6 table. 6 times 6 is 36. So there are 36 possibilities. So what we're going to do is get to example 3 and deal with the rolling of 2 dice. Now, they're going to say that you imagine that a dice is rolled twice. It's the same thing as rolling 2 dice at the same time. And let's deal with event A. We want to find the probability that the sum is greater than 9. So if we're greater than 9, we are bigger than 9. We could be at a 10, 11, or a 12. Those are the numbers bigger than 9. So I've got 36 possible, and you can count these up. There are 3 10s, 2 11s, so 3, 4, 5, and 1 12. That's 6 in this red bubble that I just drew. 6 sums that are greater than 9. We should always reduce. So the probability that when you roll your dice, you will be larger than 9, you have a probability of 1/6. For part B is a little more tricky. They're saying find the sum is divisible by 2. Well, again, I've got 36 possibilities. But if I am divisible by 2, I have to have either a 2, a 4, a 6, an 8, a 10, or a 12. In other words, these sums are even. So you could have a 2, a 4, a 6, an 8, a 10, or a 12. How many 2s did we have? Well, there was 1. How many 4s? Well, you can count 1, 2, 3 of them, right? How about the 6s? Well, we've got 1, 2, 3, 4, 5 of them. How about the 8s? 1, 2, 3, 4, 5 of those. How about the 10s? 1, 2, 3. And how about the 12s? Well, you can see there's just 1. Well, 5 and 5 is 10. 3 and 3 is 6. So you'd have 10 plus 6. And 1 and 1 is 2. And, you'd get 16 plus 2. You have 18. How about that? Half of those numbers are even. It's probably what you would have guessed. When you simplify, when you divide the top and the bottom by 18, you will get 1/2.